Hi, everyone, and nice to see so many people already connected. Hello, good afternoon, good morning, good evening. My name is Miriam Gonzalez. I am doing partnerships in O42, and I will be your host today. Welcome to our webinar, Why You Should Add Satellite-Based Analysis to Your Vegetation Management Solution. So today we have incredible guest speakers from the companies Spacept, Stair Blue, and of course, O42, with wide knowledge in this industry. But before we start, let me remind you how to use these webinar tools. On the right side of your screen, you will see different tabs. You will see the questions tab, the chat tab, the polls, and also people. So please, during the presentation, start doing some questions. And also, if you see questions that you are also interested in getting some answers, please feel free to vote for them. So our Q&A ninjas, they will be answering during the session. And also at the end, all the voted questions will be answered by other speakers. Thanks a lot for being here. Feel free to start in the chat saying who you are and also where are you calling from to this webinar. Thanks a lot for being here. All right, so to start using the tabs poll, let's do the first poll for today. And the first poll is, what industry are you working in? Okay, thank you. So now let's jump to the main topic of this webinar. So what is vegetation management? Vegetation management is the monitoring and timely removal of vegetation that could pose a risk to infrastructure such as railways and transmission lines. So what is the industry today, and also what has been the industry in the past few years? So traditionally, vegetation management is a manual process. Some companies have an army of inspectors who will need to do in-situ inspection. This is a repetitive process, very costly, and also time-consuming, and of course, inefficient. That is why vegetation management is often the largest cost center for utilities providers, exceeding more than 100 million in many larger companies. So how is this relation to environmental risk? So we already know nature is unpredictable, especially during these times in the ones we are witnessing how extreme weather events are getting stronger. This year in several regions of the globe, they face the worst heat waves in decades. Flooding like the ones in Germany and also around Europe, in the ones in 2 months of rain they will receive in 2 days. All these extreme weather events will continue. Back in October 2017, in Northern California, all these fires were caused by utility electric power equipment. So the good news is that at this moment we are living in a maturing satellite industry. There is more than 6,000 satellites already orbiting on our Earth, and so many constellations that will be launching in the next years. So that satellite imagery can help generate highly accurate information for areas of thousands of kilometers, and also being able to analyze the vegetation health, height, and also identifying risks that will require immediate attention. So now let me show you also how O42 can be supporting companies with their special challenges. So O42 is a development platform and marketplace, which goal is to derive insights from your spatial data at a scale. So we want to really enable developers and also companies to build solutions based on your spatial data and analytics. As you can see here in this slide, our marketplace has more than 120 data and analytics at this moment. We have satellite data, aerial, radar, elevation data imagery. Also, we have process data sets for weather and also for maritime industries. And also in analytics, we have statistics and also indices, and of course, machine learning algorithms. So related to this last category, I can share with you this use case that we have right now also available in the platform. So, and also related, of course, for this webinar. So first you have to go to the catalog search to do this kind of data discovery. In this data discovery, the first step will be accessing to this high-resolution satellite imagery along electric and transmission lines, railways, or other critical infrastructure. The second step that you can use is this tiling algorithm. That is a preprocessing algorithm that will be able to support also the final algorithm that you will be using. So you have a more efficient process to be able to achieve your goal. In the third step, you can process it with reliable and powerful algorithms from Spacept that detect trees and analyze the height to allow you to identify areas of risk where the trees could fall on transmission lines or railway tracks. And of course, the insights that you are generated right here, that the process for this workload can be easily integrated into your own applications via API or also using the O42 Python SDK. So now is the time for the second poll of the day. And also let me invite, in the meantime, Sergio and also Eric to the stage, so we can do this survey in the meantime. Sergio, Eric, can you join? Thank you. All right, welcome.
Thank you, Miriam.
Sergio and Eric. So let me share with the audience who is Spacept and also your background. So Spacept is an artificial intelligence startup deploying computer vision systems which fuse space technologies and machine learning algorithms to reduce greenhouse gas emissions, protect infrastructure, prevent forest fires, conserve nature, and also ultimately saving lives. Sergio Iliev is a CTO and also co-founder. He has a background in aerospace engineer. He has been doing machine learning research in the Carnegie Mellon University, Imperial College London, and also he has experience in NASA, ESA, and also investment banking. Eric Langenschog, I think I got your name right this time, Eric, finally. So Eric has a background in business development and also in B2B sales, and he has been successfully building companies and also selling companies as a serial entrepreneur. So welcome on board, and the floor is yours. Thank you.
Thanks for the wonderful intro, Miriam. Like she said, I'm an entrepreneur from Stockholm, and I simply fell in love with the idea of tackling global warming in a sustainable and scalable way using something as high-tech as satellites and AI. And to do this, we had to build some really state-of-the-art technology, and we couldn't have done it without my brilliant CTO and co-founder. Please let me introduce Sergio Iliev.
Thanks, Eric. So we've been at this for about 2 years now. We started in 2019, and it's been quite a journey, roller coaster, and very fun. As Miriam said, our expertise is a natural combination of aerospace, machine learning, and also business. And since we've started in 2019, we've expanded globally in the following year. And we've developed some very exciting technologies from both a technical perspective and also from an applied perspective, as you will see today. Our mission is to reduce greenhouse gas emissions and help companies across the world reduce inspection costs and do things in a more sustainable manner. Ultimately, our aim is to save lives. We want to protect the environment and prevent natural disasters. Over here in the image, you can see a case study of what inspired us to start Spacept in the first place. We realized companies need a modern way of inspecting infrastructure because current means don't make the cut, and they lead to mega fires like the one in Paradise, California, which killed 86 people and destroyed almost 20,000 buildings, resulting in $16.5 billion in losses. And this fire was caused by vegetation that grew too close to power lines. And unfortunately, this is not a standalone example. PG&E's power lines have caused more than 15,000 California wildfires in the past 8 years. And every year we seem to learn there's a more and more massive fire. In order to secure infrastructure, previously, one would have to manually fly a helicopter along the line or send a crew to drive and visually inspect the corridor or actually to walk the line. And this is quite inefficient, as one can imagine. And it is not very scalable. We set out to use space technology and machine learning to tackle this issue and do it on a global scale, so that organizations can avoid accidents such as the PG&E wildfires. So our solution uses machine learning and satellite data. And we do intervene in a proactive way to prevent fires from happening in the first place, rather than merely reacting to them. using these technologies, because reactive technologies have existed for decades now. But with the development of new technologies, we can detect risky areas before they pose a danger to the infrastructure and lead to fires or blackouts or other issues. So our technology goes beyond just detection of potentially risky areas that can cause fire. We can tackle most dangers to linear infrastructure, be it storms or floods, landslides, or unauthorized construction next to the line. All these can be inspected from space. In our process, we depend very much on our data sources. However, our algorithms are agnostic of the data source type. So it can come from Pleiades, it can come Airbus, Planet, or even aerial platforms and drones. For our machine learning engines, it does not really matter. However, through our collaboration with UP42, we are able to achieve unprecedented scale. And we have tailored our algorithms to work on the UP42 platform in a very efficient manner. What we generate are these threat zone maps that show where the risk is the highest and how the risk evolves along the line, so that inspection crews can be sent and drone crews can be sent where, statistically speaking, the highest risk occurs. And this has been benchmarked, as Nicolas will show you, with the gold standard visual inspection, inspectors walking the line. And we've carried out a statistical analysis of our first generation engine results. And the results are quite remarkable. Since then, we've improved significantly. This brings us to an overview of our end product, which is this infrastructure inspection technology. Through our benchmarks done in collaboration with Stair Blue and EDIS, we have inspected thousands of kilometers, but we can scale to millions of kilometers. And it's important to note that we have tested our technologies in Europe, but we have also done pilots in Australia and the States. And the technology can be applied any time of anywhere in the world at any time of the day, as long as there is daylight in that region. I'll move. This is just a slide of our customer. I'll move on to a bit more information to get the background of what can be done and what cannot be done currently with the current level of technology in satellite remote inspection of infrastructure. So satellites bring significant value, but they have some disadvantages in the sense that they cannot carry out the main disadvantages. Essentially, you can't do nut and bolt level inspection from space. Very much can be achieved, but that leads to the complementarity of drones and satellites. And as Nicolas will explain, our solutions are very much complementary in the sense that we do a global overview of the entire line, and then drone crews can be sent very efficiently to carry out the nut and bolt inspection. Furthermore, we can enjoy almost instantaneous data collection over drones, helicopters, and other manual methods. In one day, we can essentially inspect thousands of kilometers, whilst you would need an army of inspection crews in order to perform this at the same level. Now, one disadvantage is in some regions, due to cloud coverage, it is not possible to inspect the lines very often, or right after a storm, for example. but this can be alleviated to a certain degree by using a synthetic aperture radar imaging. And in order to make up for some of the disadvantages in terms of resolution, we have partnered with multiple companies, including ARP42 and Stair Blue. And we're very happy that we can together move towards our common mission, as outlined at the beginning of the presentation. This brings me to a quick overview of the traction we've achieved to date, both in terms of technology and in terms of business. This is also a very nice conclusion and overview to the presentation. So together with Stair Blue and ARP42, we've inspected a couple thousand kilometers to date. And we also saved tens of thousands of dollars in costs and tons of CO2 emissions. And our accuracy has improved to over 85% precision and recall as benchmarked on the ground. Regarding the ARP42 platform, as I said, our solutions provide a very high degree of accuracy and reliability using the data streams available on ARP42. And you can try it yourself even today. We've done a couple of tutorials on how to quickly get started on this. So given our strong success cases, we would love to collaborate and to tackle problems in power line inspection together. And going beyond this, we have some very exciting new developments that lead to inspection beyond power lines, to building inspection, oil and gas inspection, leak detection. These have just been released on the platform, and more information is about to come. So if you have any questions, concern, ask them in the questions section, as Miriam will tell you. Never hesitate to contact us. We're available anytime at hello@spacept.com. And now I'll pass it to Nicholas from Stair Blue and Miriam. And I'm looking forward to your questions.
Yeah, thanks a lot, Sergio and Eric, for sharing this presentation. It was really insightful. In the Spacept presentation, you hear how by aggregating and analyzing data of satellite image providers and inspection companies, they are able to derive insights for infrastructure operators. So the collaboration with the Stair Blue is relevant for achieving these goals. So thanks a lot, Sergio and Eric. I will invite you to leave the stage now. And then we welcome Nicholas. So Nicholas Draver is right here already, but then we need to do another poll. Thanks, Sergio. And then, so this poll is, what data acquisition technique would you be most likely to use for vegetation management? And while we are receiving some of the answers from you, let me share with you a bit about Stair Blue and also from Nicholas Draver. Stair Blue platform helps energy companies monitor their assets thanks to drones, helicopters, or satellites. It outputs actionable reports for the operations and maintenance teams. And Nicholas Draver is also an aerospace engineer, and in 2016, he co-founded Stair Blue. At Stair Blue, he was recently in charge of the operations and deployed the Stair Blue solution to utilities around the globe, like AEP in the US, Enedis in France, and also PowerLink in Australia. Nicholas, the floor is yours. Thank you.
Thanks a lot, Miriam. So, hi everyone, I'm Nicholas, and as Miriam said, indeed co-founder and chief product officer of Stair Blue, and I'm very glad to be here. So Stair Blue started in 2016 with the ambition to write software for drones and automate energy and infrastructure inspections, like wind turbines, power grids, and cooling towers, and so on. Well, over the years, we have extended our platform to accept more and more data sources, and today we can handle helicopter images or satellite images. And we have expanded to be a one-stop shop for utility companies for visual inspections of their infrastructures. To give you an overview of our product, we have a clean and simple workflow for our customers. Well, first, they gather clean data thanks to automated drones, which ensure consistent distances from the infrastructure. Then these images are uploaded to our platform where experts can analyze them. and the analysis is compiled into an actionable report, and we deliver it to the asset manager. In the end, the operations and maintenance teams can take the appropriate actions and repair what needs to be repaired. Well, we have customers in many different countries, and for most of them, we usually deliver detailed inspections using drones. However, since 2020, together with Spacept, we have started providing vegetation analysis from satellite imagery. And today, we'll focus on Enedis. Enedis is the largest European distribution system operator. They manage a grid of a medium voltage grid of 300,000 kilometers and a low voltage grid of 500,000 kilometers. DSOs have several needs when it comes to inspections. So we'll show you some of those needs. It's a non-exhaustive list. And I mentioned earlier that we have usually been focused on detailed asset inspections with drones or helicopters, but for a year now, we've been providing vegetation analysis together with Spacept. So let's go through some of the requirements and challenges we faced when providing this product for Enedis. Well, the vegetation management for Enedis consists of locating and classifying the images in a corridor of 15 meters around their grid. The volume is quite large. They inspect every year 1/3 of their grid, of their medium voltage grid, and they have been using mostly ground patrols, though they have been introducing long-range UAVs in the past years. It's still mostly ground patrols who are performing inspections today. Well, in terms of expectations, they want us to assess horizontal and vertical clearance from the vegetation to the conductors, so not the central axis, but to the conductors, which is a big difference. And like you can see on the schema on the right, and each of the detections needs to be classified with one of the 4 available labels. And the highest emergency level, the U0, is for any vegetation closer than 60 centimeters to the grid, which is quite challenging for satellite imagery. Sometimes it amounts to 1 to 2 pixels on the image, so it's a challenge. Another challenge is to precisely locate the power line. Some regions only have blueprints of the grid locations, so we cannot say if there is a vegetation within 60 centimeters from the line without first precisely locating the power lines. So this is often the first step when we work with them. The next challenge is classifying the vegetation, which is underneath the line. Satellites are very good at horizontal distance, but it is not so easy to assess the vertical distance. There are some solutions though. Don't hesitate to ask questions if you're interested in this. So we created with Enedis a special category for vegetation, which is under the line. So some utility companies we met thought they could switch completely to satellite-based detail inspections and get rid of drone and helicopters inspections. So even though it's the ultimate goal, we're not going to lie, it's not yet possible. And the image on the right shows what people who are not in the industry expect when they hear the word satellite. And the image on the left is what a drone would capture from relatively high above. The reality is shown in this image, which looks similar to Google Earth, but here the date when the image is captured is controlled. Utility companies like Enedis ask us for precise vegetation analysis at a given date. So we ask Spacept to task a satellite or use an image that is less than usually 3 months old. This ensures that images we use are not obsolete from years ago, like you could find on Google Earth. So on the image, what you see is the overlay of the image, which was captured by Up42 and Spacept. You see the vegetation detections detected by Spacept, and we overlay the grid. And we translate this in a file which is compatible with the information system of our customer, which allows Enedis, for instance, to directly assess the cost of the pruning of the encroachment. So for Enedis, it's, for instance, a simple Excel file where vegetation detections are grouped together. Each line is one of those groups. In order to deliver better analysis for NEDs, we had a quality feedback loop. So once we started working with Spacept, we had a few drone pilots on the ground checking if our analyses were accurate or not. So the images here shows our drone pilots on the right-hand side taking images of the highest emergency detection along the line. And it turned out to be a false positive. So what was detected here as a potential emergency U0 is in the end only a small bush under the pole. And this helped us to incrementally improve our results for following deliveries by making the model better. Now comparing the different inspection methods along various axis or criteria. So for productivity, there is no game. A satellite is clearly faster than a man working under the line or even a drone flying above the lines. For resolution, drone provide resolution images which can be as good as 1 millimeter per pixel. So which is great to perform some detailed inspections where utility companies look for broken insulators or small spot of corrosions, or to perform some inventory analysis of the equipment on the grid. But the resolution of satellites is enough to perform some vegetation analysis. Precision and recall, for the people who are not familiar with those terms, lot used in machine learning or AI, is precision is about detecting too many or not too many, let's say, trees in our case, which are not actually trees. And recall would be the fact that we miss some detections, which can be in some case critical. And so the satellites, thanks to this feedback loop, is able to cope with most of those misses by having models which improve over time. But it's true that the resolution is at the limit of what some utility companies are looking after. And the last one is cost of acquisition, where thanks to its productivity and having automated vegetation detections, while satellites is clearly a better solution for vegetation analysis. But to recap and conclude, so here are some of the key success factors for our work with NEDs. So first, we had to adapt requirements to satellite constraints. So classify specifically the things that are below the lines, because satellites are limited to assess precisely the vertical distance. Find the right balance between false positives, false negatives. So if we, for example, utility companies in California cannot afford to miss any detections close to the grid because of the risk of a fire. For the north of France, it's not strict that they accept a few false positives, so they are not cluttered with too many false positives. And last one, incorporate a quality feedback loop allows the model to improve over time. So that's it for me. Thank you very much. If you have any questions, do not hesitate to leave them in the questions tab. And thank you.
Thanks a lot, Nicolas. You really helped understand how combining these technologies, you can also add a detailed service rather than just monitoring at a larger scale. Thanks a lot, Nicolas. I invite you to leave the room now, and I will invite you to come back a bit later. So last but not least, I would like to invite Sergi's son to the stage while I share with you our next poll. What are the most important insights for you to get from a vegetation management solution? Sergi, I see you're here. Perfect. So Sergi is a customer support engineer at Up42. She has a postgraduate studies in geology and also in earth science. She's passionate about earthquakes. Part of her research project were done in South America and looking at earthquake patterns in the San Andres Fault using DEM and SAR. In Up42, she enables customers to build powerful geospatial products by assisting with the technical aspects of the platform and managing the acquisition of tasking imagery. Sergi, the floor is yours.
So hello, everyone. My name is Solgi, and I'm a customer support engineer here at Up42. As Miriam had mentioned earlier, I have a background in geology, and through geology, I often work with geospatial data. I'm also one of the faces behind the Up42 support channel, and I love providing support to all of you, whether it concerns questions on our processing algorithms, navigating through our platform, or for help ordering data. But today, I would like to show how you can use Up42 to acquire satellite imagery for your vegetation management solutions. But first, Here at F42, we provide a marketplace that offers a wide range of high-resolution optical data, aerial imagery, SAR, multispectral, and more for a particular use case. In the case for vegetation management, satellite imagery provides the capture rate, resolution, and data customization that is useful in assessing the scenarios described earlier by our other two speakers, regardless of whether your AOI expands an entire network or if you want to fine-tune your analysis to something more specific. So here I highlighted some data sets that could be of particular interest, such as the Pleiad and Spot data sets, both of which can be used in processing algorithms designed by one of our speakers today, such as the change or tree detection or the tree detection by height algorithms by Spacept. We also have aerial imagery for deeper assessment of the finer tuned details of your analysis. We also offer DEMs, which could be useful in validating your analytics results, such as comparing tree heights or heights of infrastructure, such as power lines. And we also have synthetic aperture radar data, which could be useful for ground displacement studies to supplement your analysis. So through our platform, you have three major ways to search for these data sets that I have mentioned. And these consist of 1, the console, 2, the API, and lastly, the easy-to-use Python SDK. So for today's demo, I will primarily focus on the Python SDK. And the Python SDK is great for building solutions with F42 at scale. We have a whole website on the SDK where we have detailed guides and tutorials on installing and setting up the F42 Python package onto your own machine, and as well as how to do other functionalities through the SDK. But for today, we will focus on the catalog search capability through the archive collection for Pleiad, Spot, and Sentinel satellites. And we do so by defining our search parameters and our AOI. And you can inspect quick look previews and get price estimates, as well as ultimately place an order all through the SDK. So let's set the scene and take a look at the wildfire that had wreaked havoc in Sonoma County in California back in late 2019. The source of the wildfire was due to a power line failure. When energy infrastructure, such as power lines, are within close proximity to vegetation, there's often an elevated risk for power outages and wildfires. So in order to prevent events like this in the future, close surveillance as well as routine inspection of these areas are absolutely necessary. Other methods, such as manual ground surveys or drones, can be too time-consuming and costly for wide-scale analyses of power grid networks. So this kind of use case, satellite imagery is an efficient and cost-effective means of performing the same kind of analysis. And in this demo, we will take a small look in an AOI in Sonoma County and browse through the catalog to see if there's any imagery for this event. And now I will just quickly share my screen. So I hope you can all see this. Assuming that we have the F42 Python package installed, we first start by importing the F42 library. Then we need to authenticate ourselves through our project ID and project key, both variables which can be found in your project settings in console. Here I have these credentials stored in a JSON file. Next, we start up the catalog and we read in the AOI file, which in this case is a power line in an area affected by the wildfire. In this case, I have this file labeled as powerline GeoJSON. Now, we get into the fun part by defining our catalog search parameters. I first make sure that the geometry filter uses my AOI that I had previously set up in the last step. I also define the acquisition start and end date to the month of the fire. For my satellites, I chose both Pleiad and Spot to see all the possible high-resolution optical results that I can get. Next, I defined my maximum cloud coverage to be around 20%. We don't want anything higher because that could increase the chance of clouds in our AOI. I also made sure that we sort the catalog results by acquisition dates. And lastly, I specified that I would like to get back maximum 20 images through the limit filter. And here I've just listed out the search parameters that I've just explained right now. And as you can see, we have around 20 results for our catalog search. And you can inspect all these results and the information provided in this table that is shown here. And this information includes acquisition dates, outputs, cloud coverage, sensor, and also even an estimate for when you can expect the results to arrive in your console. For the sake of the demo, I've just reduced the results to around 5. And this is what you can see here, where I've isolated the first 5 IDs of my catalog search results. And I've also displayed a table again for these 5 images here. You can also download and view these quick look previews and inspect how each image would look within your AOI. I've shown them here with the AOI overlaying over the 5 images to see how each scene would cover the AOI specifically. And I've also plotted them here individually for more further inspection. And you can, of course, get a price estimate for your images before purchase, which we always highly recommend that you do. And here we're looking at how much the first image would cost us, and that would be 14,712 credits for the first image. And lastly, if you're happy with the results and you're ready to go, then you can, of course, purchase the image by placing an order. So I will stop sharing my screen. And yes, however, if you can't find an image through the archive collection, you always have the possibility to task a satellite with us here at F42. And what this means is that you have more than the archive collection at your disposal for your projects. And we can fill in those gaps where the archive collection lacks. You can also get the custom data that you need for your project needs. So in the case that you need imagery in a specific time window in the near future, or specific cloud coverage, or specific mode of capture, you can provide us with all this criteria, and you may receive your bespoke imagery. And lastly, a huge benefit of tasking with us at F42 is that we do all the hard work for you. You simply give us the requirements, we recommend and even advise you some options for the best suited provider, and we handle all the bureaucracies and complexities behind the whole tasking operation for you. In this way, there's a reduced required number of channels between yourself and the data, and you can simply expect the data to arrive in your user storage, which you can access via the console, API, or SDK. Currently, what you can task with Up42 consists of the optical data sets such as Pleiad, Spot, Head Aerospace, and ComSat. For synthetic aperture radar, we offer TerraStar X as well as ComSat 5. For elevation models, we have the hexagon digital surface models, and for hyperspectral, we offer Head Aerospace Hyperscan. But of course, you can view all of these yourself, as well as the individual classifications for each satellite and their provider on our very own ordering page, which is accessible under the Marketplace tab on our homepage. And you can initiate this process there by using the form provided. And just like placing archived imagery through our catalog, you can expect to find your task orders delivered directly to your user storage, which acts as a nice collective space for all the data that you order through F42. And once the data is delivered to your user storage, you can easily download your task data directly from the storage to your local machine, their user interface, or you can even access the data directly via the API or the Python SDK. From there, you can integrate your data into your own analytics pipelines for a more scalable approach. And lastly, we soon expect to have the feature where processing from storage can be possible. This means integrating tasking imagery as well as cold archive imagery into processing algorithms, such as the algorithms from Spacept that were mentioned today. So I hope I piqued your interest on data search through Up42. And of course, if you have any questions, please ask away.
Sergio, thanks a lot for this explanation and also showing us how to satellite imagery acquisition. Sergio, please stay on the stage, and I would like to invite now Sergio, Eric, and also Nicolas to come back to the stage for the Q&A session. And while we wait, let me share with you the last poll of today. Do you have experience processing or consuming high-resolution satellite data? Okay, so now we have everybody on board. Thanks a lot for joining again, Sergio, Eric, Nicolas. And we have a few questions. I saw that some of them were already answered. But anyway, let's go to maybe the ones that have more votes. So one of them is, how do you map the transmission lines in the first place? I saw Nicolas was replying. So if you want to share the answer, Nicolas?
Yes, I share it now. So there are different possibilities, and it's often depends on the country. But let's say the general method is to order the satellite imagery to Spacept and F42, and then we are able to see the poles, if it's distribution lines, or towers, if it's transmission lines, on the images, and so we're able to position back the poles and towers on those images. and which allows to have like a metric accuracy of the grid. In some cases, some countries have LiDAR data for the entire country, like Belgium, so we can use this data, which provides even better accuracy.
Awesome. Thanks a lot, Nicholas. Could you mute the notification, please? Thank you. So this is another question from Antonio. Can you assess the tree species? Different tree species have different fire hazard profiles, for example, eucalyptus versus oaks. I think it's a question for Eric and Sergio.
I can answer it, and we can see absolutely families of trees, so pine or leaf and such, and bush, of course. I wouldn't say specific species. However, we can also see if the trees are alive or dead, which is certainly a factor in fire hazard.
Perfect, thanks. So we have another good question here from Jan Trabek. Can you please describe how you are analyzing the vertical proximity of the vegetation to the power lines?
Excellent question. So for that purpose, we can either use stereo images, so image pairs, and then use the parallax effect to determine the height of an object. However, those tend to be expensive and quite limited in terms of satellite availability. Thus, we have experimented with a new method of doing things. For objects that have a ground shadow, we can use the information of the shadow along with our Spacept detection engine to mark the shadow, determine its length, and knowing the satellite position, the position of the sun at the time of image acquisition, we can infer the height of an object and do that at a cost an order of magnitude lower than stereo images. So we have experimented with that in Sweden and France as well. If there is a strong requirement to determine the height of the tree, that is a possibility as well. Thanks for the question.
Perfect. Thanks a lot for the answer, Sergio. And I think we already went a bit over time, so let's have one more question, and the rest, sorry, but we are going to be trying to answer those offline. The question is from Arief Azar. What are the resolution and accuracy of satellite data you use?
We're pretty agnostic to the source, and so it depends on where we're buying them from. It's usually not necessary to go to the fullest extent of the resolution. So a meter usually suffices. Half a meter can be also very useful. You can go even more detailed with synthetic aperture radar, but that's not really necessary.
Thank you, Eric. So I will go for one more question and then to close this webinar. Earlier you mentioned, a question from Zach Reimer. Earlier you mentioned 90% precision recall. Let's say recall sits at 95. That means your analysis method is missing 5% of actual threat instances? Or how do utilities find and secure the remaining 5%? And what has the feedback been on those missed threats?
Yes, so I can say a word on this. So first, what we need to keep in mind is that even ground patrol will eventually miss things. So even the human has rarely 100% precision and 100% recall. And second, what we do is we combine different inspection solutions. So the satellite will able to analyze quickly a large area, and then able to give drone pilots, for instance, zones which may need to be checked a second time. If you're crossing forest, for instance, we may send the drone pilots, which will confirm or not satellite detections. So it's working hand in hand with the different solutions to bring the best cost to the overall inspections.
Thanks, Nicholas, for the answer. Thanks a lot. So I think we're out of time already. Thanks a lot for all this amazing webinar. Thanks a lot, Sergio and Eric from Spacept. Thank Nicholas from Stair Blue and Sergio from Up42. Thanks a lot, and looking forward for the next webinars we can be doing together sometime in the future. So special thanks also to all the attendees from around the globe who joined today. Please don't hesitate to sign up in the platform. You'll receive 10,000 Up42 credits to start testing out the platform and evaluating how you can use it to access satellite data or build end-to-end end-to-end vegetation management solutions. In case you want to hear more about how you can become part of the partners ecosystem, you can find me on social media as Mapanauta. Also, you can drop me a line in partnerships@up42.com. Thanks a lot and see you next time. Stay well. Thank you, everyone. Bye-bye.